Hello, in this video, I will explain to you on how to solve this problem, number 16. Okay, let's read the problem first. Some insects can walk below a thin rod, such as a twig, by hanging from it. Suppose that such an insect has a mass M and hangs from a horizontal rod as shown in figure 5.17 with angle theta is equal to 40 degrees. Its 6 legs are all under the same tension and the leg sections nearest the body are horizontal. What is the ratio of the tension in each tibia to the insect weight? And then B, if the insect straightens out its legs somewhat, does the tension in each tibia increase, decrease, or stay the same? Okay, let's see what can we do from here. And here is the insect and it has 6 legs, right? So I will have 6 legs. And let's draw a free body diagram on one of each legs. Free body diagram on one leg. Okay. And maybe let's just draw the insects as a dot like this. And it has a mass of M, right? The mass is M. And then it hangs in a twig like this. So we will have the tibia looking like this. And the tension on it here, let's just name it T, right? And the angle is 40 degrees from the horizontal. Okay, so it looks like this, and this is the horizontal. We will have theta here, and that will equal to 40 degrees. Good. And then we have the insect's weight, right? That works on the insect here. So we will have, this is the force by the weight. However, because it has 6 legs and we only view it on one leg, this one will be 1/6 the mass of the weight of the insect. So I'll have 1/6 M times G. Good. Okay, now because the insect is stationary, we have the sigma F here. Okay, sigma F is equal to M times A, right? But then because the insect is hanging on the twig and does not moving, this one will be equal to 0 because it is stationary. Okay, and then on the, let's see on the y direction. But then I will need to project this T here to the vertical axis. And how to do that? Let's see here. Okay, we need to project this into this one here. Okay, let's name this as Ty. Okay, and how to calculate Ty? Ty, we can also place Ty here, and that is the opposite of this hypotenuse. If we see this T as hypotenuse, so that will be our opposite. So we will have our T, opposite and hypotenuse is sine, right? So I will have sine theta. So I will have this value, or theta is 40 degrees, so I'll have T sine 40 degrees. Good. And now let's plug that in. So sigma F on the positive direction, I will have Ty. And on the negative direction, I will have Fw, the force by the weight of the insect. Okay, and all of that will equal to 0. And then we will have T sine 40 degrees. Okay, and then we will have minus 1/6. And then we will have the mass here times the gravity. All of that will equal to 0. Good. I think our slide is full. Maybe let's just save this and continue in the next slide. Okay, now let's do some math here. So we will have T of multiplied by sine 40 degrees, and that will equal to 1/4 over multiplied by mg, 1/6 multiplied by mg. Good. But we are asked to find out the ratio of the tension with the weight of the insect. The tension is this, and the weight is this one, right? So we will have T divided by mg. So I'll have T divided by mg, okay, and that will equal to what is left. So I will have 1 over 6 and then sine 40 degrees. Good. So we will have T, or we can rewrite this mg as the weight of the insect. And I think we can calculate that, right? So I will have 1 divided by 6 sine 40 degrees. Okay, and I will have 0.259. 0.259. Okay, and this is dimensionless because this is Newton divided by Newton, so we don't have any unit here. So that is the answer for question A. Okay, that will be the answer for the question A. And then for the question B, if the insect straighten out its legs somewhat, does the tension in each tibia increase, decrease, or stay the same? Okay, we need to see the tension here. So if we isolate the tension from this equation, I will have mg divided by 6. However, the angle will change here. So I will have sine theta here. Okay, and then if it straighten its legs, okay, let's see here. If it straighten its legs, theta will increase, right? Because it will goes here, right? If theta increase. So we will have, okay, let's write that, straighten legs, straighten, we will have theta increase. Okay, and then if theta is increased, then sine theta is also increasing, right? Sine theta is also increased. Okay, however, here sine theta is in the denominator, so that will means that our tension here will decrease, right? So we'll have T will decrease. Why? Because sine theta is increased, so T here will decrease, right? So we'll have T will decrease. Okay, so the answer for the question A is this one, 0.259, and then for the question B, it will decrease, the T will decrease. Okay, and I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.